Hello everyone, this is my sample for the presentation unit on some application to integration and differentiation. I was just kind of looking around my room or my desk, seeing if there's anything that could kind of inspire me to use some kind of technique. And I decided to see if my coffee thermos actually had 12 ounces of available fluid space. So here's what I did with that. Well, my idea was to find some kind of application where I could model the dimensions of this thermos. So turns out Desmos has a really user-friendly and quick and easy way of doing that. Really easy to adjust the scaling and import the picture and all that good stuff. So I'm going to take you through the steps. We want to use coordinate plane to represent some aspect of this shape so that we can apply our application to integration. So here's what I did. Rotated the picture and then I adjusted it onto the coordinate plane so that the x-axis was sort of running through the middle of the thermos. And you can see that over here I adjusted for the actual volume of the inside versus the kind of the size of the outside. The container on the inside actually starts at about 3 centimeters in. And that's going to really be a big factor when we're calculating the volume in the end. Right? Also, about the size from the bottom to the top is about 18 centimeters, so I just adjusted the scale accordingly. Okay, well, it seems that this outside edge has some kind of curvy wave-like shape, so I decided to just try out a trig function. Here we can play with the parameters and see if we can really get it to match this path here. Find a function that represents this outside edge of the thermos. And here's what I came up with. Okay, I changed it to blue, but I also calibrated it a little bit to make sure that we're finding the volume of the inside of this and not necessarily the outside of the whole thermos. Okay? In the next slide, before integrating it, I just wrote out the function with the parameter values so that it looks a little bit cleaner when we're doing the integration. We know that we can represent this as our radius, and if we were to break this up into many disks, we would have our radius squared times pi, and then we would have, let's say, h of those to represent the volume. Okay. So we're going to square that radius as we go along the edge of the thermos, and it's kind of nice that Desmos has this integration feature. If you go to the function section, miscellaneous, and we end up getting 363 centimeters cubed. Let's see if that reaches our target. Well, I just typed in 12 fluid ounces into Google, and it came out pretty close, right? Maybe that means we have to calibrate a little bit more for the volume of the inside of the actual thermos. Okay, so here's what I would like for the class to do. Take any picture, anything you want to represent, or anything that you want to find the volume of or the area of. Use Desmos to find a function that represents some aspect of that shape or object and calculate the volume. once you get that, you can post it on the blog with the other assignments. Thank you for listening.